Download this code from codegive.com, link in the description below. Clean architecture is a software design philosophy that promotes the separation of concerns and helps ensure that the system is maintainable, testable, and adaptable to change. It is based on the idea that the business logic should be independent of external frameworks, databases, and user interfaces. This tutorial will guide you through implementing clean architecture in TypeScript with a simple example. Overview of clean architecture layers. 1. Entities represent the business rules and core logic. 2. Use cases, interactors, define the application-specific business rules. They orchestrate the flow of data to and from the entities and direct the user interface to present the results. 3. Interface adapters convert data from the format most convenient for the use cases and entities to the format most convenient for external agencies like databases and user interfaces. 4. Frameworks and drivers, the outermost layer that interacts with external systems, like web frameworks, databases, etc. Setting up the project. First, create a new project directory and initialize it. Bash. mkdir clean architecture example. cd clean architecture example. npm init npm install TypeScript ts node at type/node save dev. npx tsc init. Project structure. Create the following directory structure. /clean architecture example. /src. /entities. user.ts. /usecasses. userservice.ts. /adapters. usercontroller.ts. /main. index.ts. xconfig.json. Step 1, define the entity. src/entities/user.ts. TypeScript. Export class user. Constructor, public ID, string, public name, string. Step 2, create the use case. src/usecasses/userservice.ts. TypeScript. Import user from /entities/user. Export interface user repository. Get user by ID, string user null. Create user, name, string user. Export class user service. Constructor, private user repository, Get user, ID, string user null. Return this .user repository.get user by ID. Create user, name, string user. Return this .user repository.create user, name. Step 3, create the interface adapter. src/adapters/usercontroller.ts. TypeScript. Import user service from /usecasses/user service. Import user from /entities/user. Export class user controller. Constructor, private user service, Get user, ID, string user null. Return this .user service.get user, ID. Create user, name, string user. Return this .user service.create user, name. Step 4, implementing the framework and driver. For simplicity, we will use an in-memory repository. src/adapters/in-memory user repository.ts. TypeScript. Import user from /entities/user. Import user repository from /usecasses/user service. Export class in-memory user repository implements user repository. Private users, user equals. Get user by ID, string user null. Return this .users.find, user equals user.id equals id, null. Create user, name, string user. Const user equals new user, this dot users dot length plus 1, dot to string, name. This dot users dot push, user. Return user. Step 5, wiring everything together. src/main/index.ts. TypeScript. Import user service from /usec as /user service. Import user controller from /adapters/user controller. Import in-memory user repository from /adapters/in-memory user repository. /setup. Const user repository equals new in-memory user repository. Const user service equals new user service, user repository. Const user controller equals new user controller, user service. / example usage. Const new user equals user controller dot create user, John Doe. Console.log, created user, new user. Const fetched user equals user controller dot get user, anywuser.id. Console.log, fetched user, fetched user. Running the example. You can run the application using tsnode. Bash. npx tsnode src/main/index.ts. Conclusion. In this tutorial, we implemented a simple clean architecture example in TypeScript. We created a project structure that separates the core business logic from external concerns, which makes the application easier to test and maintain. Key takeaways. 1. Separation of concerns, each layer has a specific responsibility. 2. Independence, business logic is not tied to external frameworks. 3. Testability, each layer can be tested independently. 4. Flexibility, the architecture is adaptable to changes in requirements. This structure can be expanded with additional features, error handling, and integration with real databases and frameworks as needed.